Hello, classmates. Today I'm going to be interviewing Tuba from my dad's lab. She's going to be telling us about Krabbe disease. Hello.
Hi, Sophia.
Okay, I'm going to be asking you questions, and if you can please answer them.
Absolutely.
First question, what is Krabbe disease?
Krabbe disease is a uncommon illness seen in babies, and it affects the nerves in your body. So just like telephone lines carry information between different parts of a city, nerves carry information back and forth from the brain to different parts of your body. And in Krabbe disease, nerves over time start working slow and eventually stop working. This means that there is lack of communication between the brain and other parts in the body. For example, the brain may tell your arm to move like this, but your arm may not be getting this message. So the body eventually stops working because it cannot get the proper messages and will no longer be livable, unfortunately. So as I said, Krabbe disease is mostly seen in babies. Unfortunately, these babies do not survive beyond 2 to 3 years of age, and there is no cure for the disease. If the babies get treated soon after they're born, they have a chance of living a little bit longer, but eventually die of the same causes. And therefore, it's important to find better treatments for human babies who suffer from this disease.
All right. Question 2. How is your work related to Krabbe disease?
So I am trying to understand how the disease happens, basically. We know what causes the disease. It's a substance called cytosine that accumulates to harmful levels in the body and causes a whole bunch of problems. We know what causes it, but what we don't know is how cytosine causes these signs of illness and even death. So my interest lies in finding out what goes wrong and maybe using that information to come up with better treatments for human babies at the end. So I look at, what I basically do is I look at different activities that goes on within a cell in the body. So there are different cell types in the body that make up the whole organism. So I look at different activities and I look at how cytosine affects the different activities and different kinds of cells. For example, I take normal mouse and a diseased mouse, and I compare the activities between the two. So the questions I'm asking are, does cytosine cause a change in the level of activities? Does it cause an increase or a decrease in the particular activity, or even completely stop it? Does it affect different cells differently, different activities differently? And also, if we do see a change, can we make it normal again by using possibly medicines and drugs?
All right. So I know you use mice, and what do you do with them?
So I have mice here that I can show you. That I will show you 2 mice. One is normal and one is with the disease.
All right.
We call the diseased mouse Twitcher mouse.
Twitcher.
And what I do with them is, since I'm interested in different activities in different parts of the body, what I do is I take normal and diseased mouse and I compare different tissues, such as I look at their muscles, I look at their brains, I look at their nerves, and I try to make a comparison between these kinds of activities that I talked about and see if anything is changed in the Twitcher, in the Twitcher mouse. And here you can see, if you look here, this one is actually a normal mouse. You can see it's walking around normally.
Right.
It looks healthy, and when I lift it up from the tail, you can see that it sort of stays still.
Right.
So this is a normal mouse. We have a diseased mouse here, and if you look inside the cage, it's moving slowly, it's shaking a little bit,
Right.
And it's having a hard time moving around because his muscles are weak. Again, the brain cannot properly talk to the muscles and tell them what to do. So
when I lift it up by the tail, you can see that it starts shaking.
Right.
And the legs start crossing over each other, so that's a sign of illness. And also, if you look at it closely, the back is hunched over, which you don't see in the normal mouse.
Right.
So I take these mice, as I said, I look at their muscles, I look at their brains, and I also use a needle to inject the sick mouse with different kinds of medicines and see if they feel better. And I can tell this whether they're feeling better or not by looking at the way they move, and there are other ways to also test whether they're eating properly, they're gaining weight properly, and the way they move. You can tell whether the medicine worked or not.
Right. All right. Question 4. Is the disease in the mouse the same as the disease in humans?
It's very similar. It's actually similar enough that we can study the disease in the mouse and learn a lot about it. So obviously mice are not humans, so eventually what we find in the mouse will need to be applied to humans to see if it works. But the disease is similar enough that if we can come up with a treatment that's better and that works in the mouse, we can hopefully take that treatment and try it in babies also, and hopefully that will work.
All right. How does studying the mouse help with curing humans?
So, working with humans is difficult, and it also does not allow for experiments to be done. So the advantage of using mice is that we can do different kinds of experiments. We can breed as many mice as we want to be able to do these initial sets of experiments. And as I said, the disease is similar enough that what we find in the mouse will hopefully be applicable to humans. And what's best about mouse is that we can find out what happens in the disease in a much faster manner. We can't do that with the humans, unfortunately. So what we do in mouse gives us, even though they are not humans, it gives us a lot of very important tools to study the disease and come up with better treatments in a much shorter period of time, so that we can apply that to humans eventually.
Right. So as you told us before that humans usually can live up to like 2 to 3 years, right? How long can the mice live?
The mice in general don't live as long as humans. A normal mouse can live up to 2 years if taken care pretty well. So the diseased mouse on average lives anywhere between 40 to 45 days, and compare that to 2 years. So that roughly translates to 2 to 3 years human life compared to a full life length.
All right. Thank you, Tuba.
You're welcome.
And, yep, hope that everybody now knows what Krabbe disease is. And, yeah, goodbye.
Thank you.